We're going to do 3.2 least squares regression. First, we're going to do the warm-up, the review of 3.1. So we have the miles driven and price in dollars of 16 Ford F-150 Super Crew 4x4s. What is the explanatory variable? Miles driven. That's our X value. Because we're trying to predict the price of the car based on the number of miles. So miles is the explanatory. It explains our Y variable. So our response variable is the price of the truck. Linear correlation coefficient. So if we put our data in, remember, so we put it in our two lists. Then we can do stat, lin regression, and we get our R value of negative 0.815. If we're using the Inspire, we type it in the listen spreadsheet, Control I, get a calculator page, and menu, statistics, stat calculations, and linear regression as well. So we have miles and price is what I labeled them. And we get our R value here. So we got the same thing. So it's negative 0.815. So describe the set using new socks. The relationship between miles driven and price of Ford F-150 Super Crew 4x4 is a negative, strong, linear relationship with no obvious outliers. So one of the things that we want to make sure that we have in here, so shape is linear, outliers right there, C correlation, and that's our negative, strong, and that's what we need. So now we're going to look at least squares regression, or least squares regression line. It's a line to predict other values. So if, well, we already looked at this, we have our line. A is our slope here, it's before x, negative 0.1629, and B, our y-intercept, 38257.14, because we're dealing with money. Same thing here, we have our M and our B. So we already have it from finding our R value. So it's y hat, which is the predicted y value. The hat means it's predicted. Equals negative 0.616x plus 38257.14, or price hat, predicted price, equals negative 0.16 miles driven plus 38257.14. So we can put in what the variables are instead of just using x and y. Might make more sense. What does the slope mean? Well, that's what it is. As x goes up by 1, what happens to our y value? For every 1 mile driven, the price of a Ford F-150 Super Crew 4x4 decreases, because it's negative, by 16 cents. Or we can multiply it by 1,000, get 160 bucks per every 1,000 miles driven, or whatever multiple you think makes more sense. What does a y-intercept mean? Well, that's our y value when x is 0. So if x is 0 means has no miles driven on it, then it should cost $38,257.14. So our slope is as x goes up 1, y does our slope. And the y-intercept, when x equals 0, it's our y value. So that's what we're dealing with, slope and y-intercept. In context. Tell me what they mean in the context of the problem. All right, extrapolation. Extrapolation means that you can't predict if it's outside your x values that you have. If you look at our x values, we have 70,000, 129, 140, down to 4,000. So between about 4,000 and 150,000 would be inside of our x values. So the question, what would be the expected price of a car with 200,000 miles on it? 200,000 is much bigger than all our x values. So it is outside of our interval of data. So predicting the cost would be inappropriate because it just doesn't follow our model. We can predict it within our X values. What would be the expected price of a car with 100,000 miles on it? That we can do. So we plug in 100,000 for X in our equation, and we got a Y hat, or a predicted value, of 21,965 and 28 cents. So if it has 100,000 miles driven on it, we should expect to pay about $22,000. Now, if I own one of these trucks with 100,000 miles on it and I bought it for $19,000, what is my residual? Well, residual is observed minus the predicted. It tells us the difference. The observed, our actual data, was 19,000 minus what our predicted was, so negative 2965.28. So what does that mean? It means that I paid $2,965.28 less than what our predicted value would be based on our least squares regression line. So I got a deal, or I robbed someone. So here we can see what the value would be. 100,000 here would be here. So that's why our price is the 21,965.28. That's about what that is. And here you can see the residuals. The points above are positive, so we have a difference there, and points below are negative residuals. A residual plot is a scatter plot of the residuals against the explanatory variable. So that's how we can tell if we have linearly related data. Just like we had for the normal probability plot, well, we have this to see if it's linear relationship. So remember, if we went back to the data that we looked at on Monday, yeah, we have a line that's pretty good. Except if we go to our residual plot, we can see a pattern. It's parabolic. So linear would not be the way to go, would be a power. And look at the residual, they're directly on the line. They're not different at all. So to find a residual, for the 84, it's kind of a process. So once we find this, you'll notice when you hit this, you have residual down here, number 7. So we'll go to Edit, and if you click up to where L3 is, and you hit second list, and you type in 7, or go down and click on it, and you put the residual where L3 is, it'll put all the residuals there, and it'll graph them. But you have to go to second, stat plot, and turn off our first plot. And then go to our second, turn it on, and we'll just do a scatter plot where our X list is L1, so our X values, and our Y list is actually the residuals, not our Y values. Then when we graph it, zoom, stat, and we can see a residual plot. There's no pattern. That's what we want. And what that's doing is just straightening out our least squares regression line, is showing how far above. This point is above, this point is above, this point is below. So we just kind of straighten out our least squares regression line. That's really what this is, and this shows us how far off these points are from our least squares regression line. So if we look at the Inspire, it's a little bit easier. If we do Control I and Data and Statistics, click here, put our X value, our miles, here our price or Y value, we have our scatter plot. Do Analyze, Regression, and Linear, we have our equation. We have to have that before to get our residual. And then we go to Analyze, so Menu, Analyze, Residual, and Show Residual Plot. And now it shows it. You can see that this point is a little bit above that. Well, that's this point. It shows us how far off it is. And so this is really just this straightened out. So that's how we find our residual plot. So is it linear? Yes, there's no distinct pattern. We don't want a distinct pattern. Coefficient of determination, R squared. It tells us the percent variation of the Y value predicted by our line. So R squared is just our R value, our linear correlation coefficient squared. But when we looked at this, our R squared is right here, 0.6642. And it's always going to be positive because it's something squared. Again, with the 84, our R squared was also here. So all this data was here on Monday, we just didn't look at it. So it's 0.6642. It means 66.42% of the variation of our response variable, the price of this truck, is predicted by our least squares regression line. It's really how good our line is. Standard deviation of the residuals. Now what this is it tells us really on average how far off we are on all our values. So this is kind of a lot of work to find our residual here. So we go to stat and over to tests, which we won't do until second semester. We go to linear regression t-test. Don't worry what all that stuff means. Just go there. X list and Y list, L1, L2, and then just go to calculate. Don't worry about anything else. And there is our S value, 5740.13. Same thing on the Inspire. Go to menu, statistics, stat tests, and linear regression t-test. We had, let's see, miles and price. Don't worry about anything else. And there's our S value, 5740. So what is that? That is the average price that we're off, or the average Y value that we're off. So using the least squares regression line to predict the price of this truck, using miles driven, we would be off an average of $5,740.13 per time. So on average, we're $5,000, almost $6,000 off. So again, it's another thing with R squared that kind of tells us how far off we are. Outliers and influential points. Basically, they're what you think they are. They're completely different from the rest of our data. But outliers, if you take them out, it doesn't change the least squares regression line or the linear correlation coefficient that much. Influential points do. So if we look at this example, we have data of 19 children, no idea what it's about, but if we take out child 18, our R goes from negative 0.64 to negative 0.33, and our line goes from this to this. So our slope changes quite a bit. If we take out child 19 compared to all of them in, our R value changes a little bit, and our least squares regression line doesn't change much at all. So 18 would be an outlier. 18 would be an influential point because it changed our line. It was influential. Child 19 would be an outlier because it didn't change much. So that's the difference between these two. And that is 3.2.